This conference will now be recorded.
Okay, so I'll just go with a very basic point of view. So everyone has come to VLSI, right? So why did you choose VLSI? VLSI. Huh? PD job opportunities. Then next, be frank, yeah. I'm friendly. Okay, I'll introduce myself first. I'm Rudra. So I've been working in synthesis, complete backend, where I have covered synthesis, PED, and STA. And my work experience is greater than 5 years. Okay, I cannot disclose my company. That's secret. Okay, so if possible, I might be also covering your PD theoretical as well. Okay, now why VLSI? To be frank, when I entered, I wanted money, highly paid jobs. So that's the reason why I have entered. What is the reason about you? So I have two reasons to get into this particular field. I have studied DC, so I want to get into my field, and also the second thing is like money. So when we look both, IT hardware is the best option. So that's why I choose VLSI. Core plus satisfying of money. Now VLSI, where you are going to be having a major role, because nowadays if you consider any device, a chip is important. Okay, that particular chip is what you are going to be designing. You are trying to use a CAD tool to implement that particular chip. Okay, a certain part of that particular chip, you are going to do it. The main frame we will be telling, right? That is what you are going to be performing. So before going into that exactly, what is IC? Not full form. What is IC? Millions of transistors combined together to form one particular IC, right? Integrated circuit. That means combination of multiple circuits to form one particular chip. That's what we are terming IC. So according to that particular ICs, manufacturing, or let's say transistors level, we have is SSI, MSI, LSI, VLSI, right? So that represents based on the gates. Okay, so in starting it will be kind of revision of your engineering. After that we'll go into the actual industrial flow, what exactly we'll discuss. So IC is integrated circuit, where we will be performing is multiple transistors building. So let's say like multiple circuits, either to form one particular task or multiple tasks, right? You want that particular chip manufactured to be either to open the door or to open the door and scan my temperature. Like that, multiple task related chip we are going to be manufacturing. Now in here, according to this particular as a transistor level and also frame level, we have two types of designing: analog design and as well as physical design. So analog design, there are people who is going to be working with respect to the transistor level. That means they are going to be forming small gates and they will give it to us. We are going to be using it. Okay, analog design is related to the transistor level gate manufacturing. Where in physical design, I'm going to be using it in my flows. Okay. Now, the next term is, as I said, right, two types we have, either single or multiple usage. Now, what is a single usage term? If a chip you are manufacturing it in a single usage, what we will be terming it as? Convert what I have said to in English single term. I want that particular chip to be manufactured for a particular task. Can I say it as, sorry, go ahead. Can I term it as ASIC, application specific integrated chip? Heard about it?
Yes, sir. Yes, sir. Yes, sir.
Perfect. So we are going to be hearing nowadays, most, or let's say week from now on, you will be hearing is like ASIC flow and SOC flow. Okay, ASIC means application specific integrated chip. And next is SOC. That means silicon on chip or system on chip. So according to the usage, okay, if my chip is going to be working for a particular task, then we will be terming it as ASIC. Multiple ASICs combined together, we will be calling it as SOC. Okay, yeah. ASIC means application specific, and SOC is a combination of multiple ASICs. Okay, the flow is same, but how we are executing will vary. So, in general, this ASIC flow or SOC flow we are telling, right? It is constant. So, how that particular flow is there, and according to that, what is our role? We will be discussing now. Okay, exactly what is our particular role. Now, let's go with the flow. Generally, whenever you want any of the program to be developed, what is the first step you will try to do? In engineering, they have asked you to write a program. What is the first step you will do? No wrong. Any random answer also you can be able to provide. Huh? Manual calculation. Okay.
And then requirements, sir. Requirements. We want requirements.
Right. First is like requirement, or let's say idea. I have provided you. Let's say like to write a program to convert analog to digital coding. Now what I given you that requirement. Now what you will do? Huh? Architecture. That means how I need to develop that particular code. So I can also say, I forgot the spellings. Whatever it is, architecture. Okay, I forgot multiple spellings after coming to this industry. Architecture. So indirectly, whatever the idea I give you, you're going to be converting that idea to a flow chart. Right? So based on that particular flowchart only, you will be able to develop that code and you will implement it. Correct? So that means architecture. So this architecture people are highly experienced people, which they are going to be deciding in which particular phase of the chip, what is the voltage level, what should be the frequency, what all modules should be present. Everything this particular architecture people are going to be deciding. Okay, so as good knowledge you have, the faster you can also become an architecture people as well. Highly paid jobs. Okay, the most highly paid job in industry, architecture. Okay, after architecture, what should I do? And now I got the flow chart. What is the next step? Coding or assembling. So if there are already
Coding or
existing
gate
codes,
levels.
I need to use
Gate
that
level.
and assemble. Gate level is later.
Okay.
Presently, we will have to talk it first with respect to the basic itself. That is RTL
Okay.
coding will be happening. Here I am talking about complete structuring. After that, internally we will have that gate level representations and everything. Okay, RTL designing, where the knowledge should be known as Verilog, System Verilog, and VHDL. The programming languages, HDL languages and Verilog and System Verilog language. So once the RTL code is written out, what should I do next? Verify. Okay, so any step, if I do it, the next step should be a verification. So I have written the code, whether it is following my idea or not, also I should verify. So here comes the formal verification, where you might hear is like UVM and multiple languages. So okay, UVM and different kinds of tools will be used for this particular verification category with respect to the RTL coding. Okay, RTL designing, formal verification. So now the basic part is done, let's say. Other than this, do I need anything else? Now let's go with an advanced idea. Now you want, when you buy a phone, what is the first steps you will try to prefer? What all features you will look into? RAM, storage, processor, refresh rate, camera, and display, that is refresh rate, battery backup. So when you say processor, I'll just say quad core. Other than that, will you look into anything else? Yeah, quad core, octa core, or dual core. Other than that, what extra feature you will look with respect to that particular processor? So you will be hearing something like 2.4 gigahertz
Speed we need to see.
frequency, right? And also you will try to make sure look is like inches, right? Area and your frequency and the battery backup. This will be your main requirement, right? Based on that only you will filter it. And also the number of processes, that is sub of that particular task. Right, hertz or gigahertz, right? So that means the next I need to provide is at what frequency my chip is going to be manufactured. Okay, so here in RTL designing we have decided the modules, right? And those modules will be having registers, sequential circuits, combinational circuits, like that we will be having, and also some RAMs, ROMs. We will be having some extra processes also. So for that particular sequential circuits to be working, I need to provide the frequency. At what frequency that particular module is going to be working, that I need to define. So there might be a separated team to develop that particular STC as well. Again, I'm telling there might be, or it will be integrated with different teams as well. So that means RTL designing people might also create this particular timing constraints, SDC. Okay, and after that, so my RTL designing is done. So SDC constraints related we have discussed, that is like timing constraints. And what else I do require? What are the three terms which we discussed? Timing, power, area. So the next is like for that particular module, what is the voltage level also I need to provide? If there is any variation in the voltage level, for example, let's take our phone itself. When you turn off the data, your battery backup will be more. When you turn on the data, the battery backup will be more, less, right? Now, sorry, I think so I have repeated the same sentence. I'll repeat it. When you turn on the data, my battery backup will be less. And when I turn off the data, my battery backup will be more. So I'm using the same network adapter only, right? Network module only. But when I turn on the data, the requirement of the voltage is varying. Correct? So that means internally for that particular same module itself, different voltage levels are getting required. When you turn on the camera, I'll be requiring more voltage. So when I turn off that particular camera, the module itself turned off, right? Power consumption related techniques. Okay, there will be a separate team again to develop this particular power consumption techniques as well. How much power required for each module? So there will be a team called as CLP, conformal low power team. Okay, timing constraints, CLP, conformal low power team. Now what is the next step required? What is the next feature we decided? Area, right? Area is a physical entity. So this all which we are discussing is like logical. So area will be decided during the physical implementation only, not during the front end, or let's say logical part. Okay, now coming to this next term, how do you check the functionality of a design? It's an engineering subject. Again. Sorry, Venkatesh, go ahead.
By testing, we can do that functionality, whether it is proper or not.
Right. For that particular testing, I do require some data logic.
Sorry, sir, I cannot hear you.
Yeah, correct. So I need this to do. I think so. You're using dual speakers. Thank you. Now, so we need to do is testing. For that particular testing, there are two ways. Okay, there are two ways. First is like with respect to the chip, or let's say whenever you write a code, with respect to that particular code, you are doing the formal verification by using test bench vectors. Right? Now, once I have designed that particular chip, I'm going to be using the same test bench vectors only. But there are millions of transistors, or let's say like lakhs of registers, combinational cells will be present, right? Now to check each and individual will be an hectic task for me. Test bench writing code that particular to all that sequential circuits will be too huge, right? Now, instead of that, can I use some patterns called as JTAG, ATPG, BIST, LBIST, MBIST, stuck at 0, stuck at 1? Remember algorithms during their engineering? Heard about it? So there is a DFT, to be more specific, design for testability. Okay, design for testability. That means internal to your design with respect to the existing RTL code, I will also implement extra logic to make sure like to implement the algorithms which I want, whether it is a JTAG or ATPG or BIST, whatever the algorithm which I want to represent. According to that particular algorithm, the DFT people will try to update few of the RTL codes. If required, they will try to update the RTL codes. If not, they will try to give some extra files which we need to use it. Okay, so DFT, design for testability. I'll just give a proper term. They will try to develop is like scan chains. Okay, they will use a sub concept called as scan chain development. So by using this particular scan chain means it's a back-to-back flip-flop connections. Okay, it's a back-to-back flip-flop connections. Now, how many pins does a flip-flop have? How many pins does a flip-flop have? What are those? Let's say for a D flip-flop. Clock, set or reset, input, output. So you said 3 and give me 4 pins. Sorry. So actually there will be one more pin, Q bar. Okay, according to our requirement, it might change. Now, along with this, there might be some extra pins as well. There might be some extra pins as well. So here we are telling DFT, right? Scan chain, I said. From that particular scan chain, do I need an extra pin called as SI and SC? So when this particular flip-flop is going to be functionally working, or when this flip-flop is going to be used for testing, that is decided based on the SC pin, scan enable pin. Okay, it's based on the scan enable pin. Now, the DFT people, as I said, they are going to be developing scan chains. They will be having connections from Q to SI. Okay, the scan chains are developed in such a way that with a number of sequential circuits back to back connected. Okay, back to back connected with Q to SI connections. Clear so far? Any questions? Okay, so moving forward, DFT is the stage where scan chains are getting inserted, and those people will be responsible for testing your chip. They will be working at different stages. It's not only before, it can be after your synthesis or after your PNR, they will try to test it such that they will not be having any failure. Okay, so DFT, and after DFT, we will be having is synthesis. Okay, synthesis. So here I'm talking only with respect to the ASIC specific. Okay, ASIC specific flow. Later on I'll touch the SOC flow also with respect to in this advancement, what might be their features. So the next step is synthesis. Till now we have every code written out in the format of Verilog only. That means module, assign keywords, tran keywords, always at. In that particular format only we have the RTL code so far. When I want to implement it physically, can I use that code? No. Okay.
No, we cannot use.
Okay. We cannot use that particular behavioral code. So in this particular synthesis stage, what we will try to do here is we will convert that particular behavioral code to a gate level netlist. Okay, in this particular synthesis stage, we will convert the behavioral code to a gate level code. That means, you, as I said, right, module always at, assign keywords. So those will be converted to its equivalent gates. So for example, you know, right, always at posage of clock. That means what will be that particular cell will be representing? when we just say always at passage of clock, what we will be representing it as? It's a sequential circuit. According again to the internal code, it might be working as a latch or it might be working as a flip-flop, right? Positive edge, negative edge, level triggered. So based on that particular requirement, we will be converting that cell to its equivalent cell. Okay, tool is going to do it, but we just select we are going to do it. Okay, converting of the logical to a physical entity. That means first it will convert behavioral code to the gate level netlist, and this gate level netlist is technology dependent. Okay, from here you will actually, this is like till this particular DFT stage, we will be terming it as sign off, RTL sign off. Okay, after this, synthesis is where your backend flow gets started. Few will be saying the synthesis is a front end also, and few will be saying it's a back end also, because it's like a finalized stage. It interacts both behavioral code and a technology dependent. So that's why synthesis might be a front end and a back end. So front end and back end, there are two teams majorly. Front end people are going to be working purely with respect to the logical aspect of the design. And back end people are going to be purely working with respect to the physical aspect. That means technology, routing, cell, everything. Okay. Let's say like civil engineer. The main part of civil engineer, he will just draw it and give you. And after that, the one who is working, they are less paid. Right? Here it's opposite. They are less paid and we are more paid. Okay. So synthesis is converting of the behavioral code to gate level netlist, and this gate level netlist is a technology dependent netlist. Okay, there are various flows in synthesis as well. We'll touch up slowly. Physical aware synthesis and logical aware synthesis. Okay, whether we will be using physical aware or a logical aware synthesis. Nowadays, we use is like only physical aware synthesis. The logical aware synthesis is long gone. We don't use it. We don't prefer it actually. Okay, the next part is after synthesis, your PD starts. Physical design. Okay, in physical design, it's a separate flow. Again, we'll touch up that after covering this sign off. This ASIC flow. Sign off and chip post silicon validation. Okay, so chip will, after that particular sign off, which we have defined the main terms, right? The timing, power, and here the routing related verifications will be done. Physical verification. Okay, physical verification. So where your real chip, the densities we will be telling, right? The density related check and also current ERC. There will be all this particular to manufacture that particular chip, whether that particular chip is properly designed or not, we will be verifying it with respect to timing, power, electrical rule checks, physical verification, all that we will try to perform on this particular sign off, and we will manufacture it. After manufacturing, or let's say during manufacturing, I might get some disconnections. Manufacturing issues might be there, right? So that I need to verify. So there will be post silicon validation. They will try to verify the manufactured chip is properly working or not. Once it is properly working, they will give it to consumer. If there are any defects, they will pass that feedback to the physical design. Okay, or let's say if there is any advancement required with respect to functionality, there might be update from the physical RTL as well. Okay, only small features addition will be there. No large advancements will be provided. Okay, so post silicon validation, if it is successful to the consumer, if it is a failure, then it will be passing back to the equivalent team and they will try to advance it and they will try to provide. Clear so far? Now, as I said, till now it is an ASIC flow. Now when it is SOC, what will happen? What is the advancement? What is the advancement in SOC? Or let's say, what is the difference between ASIC and SOC?
Same thing, but here we do one particular work.
Correct. In ASIC, it's a particular task. In SOC, combining of all the particular tasks. So that means I'm integrating. Correct. So you also said, right, integration. So in this particular RTL design, we are going to be integrating. But I have already designed this particular chip and it is working, right? So now I need to integrate this particular RTL codes. So there will be again a separate tool or a separate team which they are going to be performing is called as linting. Okay, sorry, not linting, integration. Sorry, my bad. Architecture, and in this particular architecture, integration. Okay, integration is the combining of RTL designs. Okay, and they will try to verify it, whether it is every connections is properly provided or not. That I need to verify. Okay, so for this particular verification between the RTL codes, we have a separate stage called as formality. Okay, we have a separate stage called as formality. This particular formality is the stage used for verifying between the netlist. That means your RTL code to synthesis code to PNR code. Okay, very long codes I'm talking about. So RTL is a behavioral code and synthesis is an converted code. So those needs to be verified, whether it is properly converted or not, and any connections is missed or not, that I need to check pin to pin connections. So that will be done using this particular formality. Okay, dot V checks we will be having. So the next is like linting. So this is done in the ASIC also, linting. With RTL integration or without RTL integration, this linting will be performed. So this linting tool, what it will try to do here is like, they will try to verify that particular code is synthesizable or not. Okay, in the behavioral code, there will be few checks which should not be present. And as an RTL designer, I am just worried about my RTL code. I'll just write it out and I'll pass it to you. You will verify it and give a feedback. And I will update my RTL code. Okay, in this particular linting stage, we will verify that particular behavioral code is synthesizable or not. First step. Second step, it will also check for any combinational loops. Okay, it will check for any combinational loops. It should not be present. So connectivity wise, every pin is connected or not, it will try to check and give you the feedbacks. When we will try to update, if there is any update required, the RTL people will update that particular linting as well. And I forgot to mention this, there is one more team called as CDC. that is clock domain crossing. Okay, there is one more T, that is CDC, clock domain crossing. So between, if there is any connectivity between asynchronous clocks, okay, if there is any data transfer between asynchronous clocks, then how do I need that particular data to be propagated? Okay, what are the methods to be used to resolving that data conversion? So they will try to be performing that CDC in this. Okay, linting, CDC, integration can be a separate team as well. Okay, so once integration is done, again I will perform linting, CDC, and again I will go for this particular DFT synthesis, all that particular steps. Okay, with respect to, again I'm telling this DFT team, they will try to represent, or let's say they will try to create that particular separate files by using the RTL code, and we will implement it in the synthesis. So that means writing this DFT with synthesis is also not wrong. Okay, there will be parallel working. Okay, so the DFT team might be working prior to your synthesis, or working parallelly with respect to the synthesis, or working after the synthesis as well. Okay, so that means first iteration of the synthesis will not be with respect to the DFT. First iteration. From the second iteration, you will be using this DFT. That's why I said before or after or with. It can be in any stage. That's not wrong. Okay, so now coming to our particular task. So till now everyone is clear? Any questions or any confusions?
You said second iteration will be from synthesis, right?
Yeah, second iteration in the synthesis.
First iteration, you mean that we will convert this behavioral code to gate level netlist. So that is our first iteration from RTL coding team.
Correct.
Okay. So from next onwards, if anything is there, we need to, I mean, either DFT or from PD. The DFT, we should get mutually that one.
No. So what I'm trying to tell you is, your RTL code will be converted to a gate level code.
Correct.
While converting this particular while performing this particular conversion from behavioral code to RTL code, we might use scan DFT or not using it.
Sorry, echo is coming. Your voice.
Okay. Is my voice clear now?
Yeah,
Yes.
okay.
No, Venkatesh, can you please be in mute?
Yeah, I am in the mode.
No. When you unmute, the echo is coming. So once you have asked the question, please be in mute. So while trainer is answering your question.
Sure.
Okay. So in synthesis stage, I'll just write it down like this. RTL code to gate level netlist, and while performing this particular conversion, we might use scan chain, or let's say DFT provided feedback, or without using it. Okay, first phase we will be using scan chain. Without using scan chain, we will try to perform this RTL code to gate level netlist, and as we want that particular testability also to be performing, then we should also insert this particular scan chains as well. Okay, so first I need to verify, right? RTL code is properly converted. So once it is converted, I will try to use this particular scan chain. This means I'm adding extra logic. right? So with respect to original RTR code, I am performing this particular conversion. I'm mapping it, verifying it. It is proper. Okay, I'm good. So that means I will insert extra logic in this particular synthesis stage by using the information provided from the DFT. I need to verify that as well. By inserting this particular extra logic, is my code affected or not? Right? So that we will be performing in 2 stages. First stage without scan chain and second stage with scan chain. Okay. Clear now, Venkatesh?
Yeah, it is clear.
So I'll mention like stage 1, stage 2. Okay. So you will have always have to run these 2 stages. Compulsory. When you do synthesis, it is compulsory to use this particular 2 stages. So if they have provided you scan chain, then you will running stage 2. If they don't provide you scan chain, stage 1 is enough till they provide that particular scan chain information. Okay. So now let's move a little bit forward. Physical design. Now from this again I'll ask the same, physical design why? The main reason I have choose this, I'll tell you mine first. Main reason I choose is I need more let's say competitive and more thinking. This gives me that particular goosebumps. So that's why I choose this. So what about you?
Dissertation topic.
Huh?
Dissertation topic.
It's a
Dissertation topic. Project.
okay project.
Based on.
Okay. Next. Guys, don't be silent, yeah. It's not good to be silent practically. So when we become silent now, what happens is like your confidence level gets down. Though it's wrong, you raise your question, because in this particular training level, no one is going to scold you. Though it's very silly or though you ask 1,000 times, no one is going to scold you. They should explain you. Okay. So please be interactive, not now, anywhere. Even when you go to industry, please raise your voice. Only then you will be getting noticed and you will be getting appreciation letter, and you might get a 100% hike, 120% hike will be possible. Okay, please raise your voices at anywhere. So don't give your ideas to anyone. In industry, don't give your ideas to anyone. You implement it, you show it to your lead, and then you share that particular ideas to everyone. Okay, because they might score your ideas. No, because it happened to me, so that's why I'm telling. So coming now back to our particular main physical design concept. Now what exactly are we going to do in physical design? In simple terms, it's same as your civil engineering. Easiest way of your telling is like it's same as your apartment construction. No major difference. They are trying to do it in an physical cement and everything. We are going to be using is like CAD tools. Okay, developing it in a 3D, wiring, everything we are going to do. So in physical design, we are going to do the same task what a civil engineer is going to do with the help of mestris, and we are those mestris here. Okay. So first is loading all your design information. Now coming to this particular concept of physical design, first step, we according to the level of the project, how many number of people required I will be having. That means according to the criticality of the project. So for example, if I have 2 million standard cells, Okay, 2 million standard cells are around like 200 to 500 macros. Okay, standard cells are smallest logics, and macros are like your RAM, ROM, TLL, all that comes under the term called as macros. Standard cells are like basic gates and basic circuitries which are globally used, like your registers, flip-flops, AND gate, OR gate, full adder, half adder. So all the small circuitries will be calling it as standard cells. Okay, now if I have that particular 2 million standard cells and 500 macros, with the help of one person, it will be taking a long time. Okay, it will be taking a long time. Then what we should do? Share the work. That means I have to divide and conquer. Right? So from this particular physical design, with the help of this particular, again, with the help of this particular physical design team, you might also want to divide the logic. You can help in dividing that particular logic as well. The RTL code assumes like that can be a single code and he will be writing it and giving it to me. Only I will be able to know how hectic it is to perform. Then from the feedback from the physical design, the RTL code might be updated. That means he will divide the logic as well. I can ask him to divide this particular module so and so. Okay, so that also happens based on this import design, and based on that particular criticality, everything I'll try to look into it and I'll provide the feedback. If it is taking more time or if it is getting complex more, then I'll give a feedback. He will divide it and give it back to me. Then I will use separate people for that. Okay, so first iteration is either based on the complexity to divide the logic, can be updated. So second thing is, basically first term we will always be using is like a chip level. Let's say when you design any, let's say I'm giving an idea of a phone construction, you will architecture will try to represent it like a chip and he will give it to you, right? So first let's consider the chip itself, chip structuring. It can be either in a square shape or a rectangle shape or an L shape, U shape. It can be in any shape except circular. Okay, except circular shape, we prefer of having any shapes which is having proper edges. That's what we represent. That's why I said L, U, X, like that we might have it. And X also will be similar to H only. Okay, now coming to this particular import design or design planning stage, when it comes to the chip level, it might have different modules, right? And those modules are working in different tasks. Let's say, as we said, camera module, network module, video, audio, processing, controlling, power, all that we will be having different modules. Power controlling related, all that we will be having different modules. Now I need to decide in which particular location that particular module needs to be placed. Okay, Shastra we will see, right? Whenever we decide our particular homes, where that room needs to be placed, we will try to see. Same like that only we will try to see here as well. Where that particular modules to be placed and in which particular shape, what should be the size. Everything gets decided in this particular floor import design stage and also floor plan. So that's why I said it's like design planning. Okay, so I'll again talk about in floor plans the same criteria only, but with a little advancement. In design planning stage, exactly area requirement I will try to provide, and also what will be the area of each and every block requirement, what will be the shape of it, I'll perform it in this particular design plan. Okay, the shape of each and every block that we are telling is like separate modules, right? Camera module, so I'll be telling here as a block. Okay, I'll be terming here now, from now it's a block. That means one person is going to be holding that particular block. Okay, you might be a block owner or a multiple block owners as well. Okay, so what we are going to be performing right now is in the design planning stage, the area requirement, the location of that particular blocks, and that particular block shape and size. It gets decided and it gets passed to individual block owners. Okay, I'll decide, let's say I'm the chip owner. I'll decide the shape. Okay, you do camera module, you do audio module. I'll share it to you that particular shape and size. With respect to that shape and size, you are going to be designing that particular module. Later on stages, I'll take your blocks and I will integrate into it. Okay, this is what divide and conquer is. So in design planning and import design stage, with respect to the inputs provided, whether I need to divide or should I do it in a single go. If I have 1 million standard cells and 50 macros, I can do it in a single go. I don't need anyone help. Okay, with 5 months of duration, will I be able to do it or not? That's what requirement is. Okay, if only one person is able to do from RTL to sign off without dividing the logic, then we will be calling it as a flat level design. Okay, flat level design, that means RTL to GDS without dividing the logic, and I'm proceeding. There might be multiple modules, but only one person is going to do it. Okay, I might take help, but I'm not dividing the logic. I'm with that particular RTL to GDS, I might take different people help itself, and based on that I'm going to be performing. Okay, that is called as flat level design. The next step is hierarchical design. So I said, right, dividing the logic, hierarchical design, dividing the logic and performing it with respect to 2 or 3 blocks. Then we will be terming it as an hierarchical design. Okay, dividing the logic and taking the help of different people to perform my task itself, divide by dividing the logic. That means block 1 is assigned to me, block 2 is assigned to, let's say, Vasant, block 3 is assigned to Reddy. Okay, so like that, different people is performing in that particular design itself. Then we will be terming it as an hierarchical design. Okay, 2 types of structuring: flat level, hierarchical design. So based on your information provided, that means your count, complexity of the design. Based on this only, we will try to either divide it or perform it. Okay, so in design planning stage, I'll try to perform the base level structuring, and I'll try to provide you pictorial representations. I'll provide you. So comes the next stage. Okay, this is with respect to the chip level. Design planning will be performed with respect to the chip level, with respect to the inputs provided. So the next stage, once I have provided you that particular structuring of your block, what you will try to perform? You will start to construct, right? On that particular construction, what you will be giving you the first priority? Base. So that particular, yeah. Yeah, Venkatesh.
I'm just saying it is area. Please continue.
Okay. So that's what. So base, as you said, right? That base is decided based on the area which I require. So he has provided me, that means the chip level has provided me the shape and size of it. I'll try to utilize that particular shape and size properly in this particular flow plan. That means the first priority after you get that particular area, you will try to construct is what? Yeah, basement is provided, let's say. From that particular basement, what you will try to do? You will start to construct what are bigger rooms are there, you will start to place them first. Which require more power, you will try to place them first, right? If you have a theaters, you will try to put it in the base itself, right? When it goes to top and top, the power I need to control it becomes difficulty, right? So theaters, when it goes to multiple force, the power controlling circuits I need to develop more. So that's why what the first step that we will try to do here is like what all bigger building blocks are there, that we will try to place it first. What were the bigger building blocks of your design? We have two categories of cells discussed earlier, right? Standard cell and macros. Macros will be the high power hungry devices. So in this particular floor plan stage, we are going to be placing them. Okay, we are going to be placing them first. So that means here also we have internal to floor plan, we have a flow creating core and die area. That means internal boundary, external boundary. Okay, internal boundary is called as core and the external boundary is called as die. Okay, so in this particular region is called as IO clearance. IO clearance area. The spacing between your die and the core is called as IO clearance area. Okay, inside this particular core is where all your logical cells, or let's say we have converted it into physical, right? The physical objects will be placed, like your cells will be placed inside the core area. Okay, and in this particular IO clearance area, we will be having is like ports placement. In the IO clearance area, ports placement. In the core area, we will be having is like cells placement. Okay, so I'll make it like pad also. So you will, when you go to theoretical part, you will be hearing about pad, port, pin, terminal, all that particular terminologies. Okay, there is a difference. So that when we go to advanced topics, we can be able to discuss about that. Right now, I'm not going to touch that. So in IO clearance area, the pads or ports or pins will be placed. Okay, the die boundary is the external boundary of the chip. Core boundary is the internal boundary where your standard cells, your routing of that cells, everything is going to be happening. In simple, I'll just say like internal to your die, all the routing will be happening. Okay, and all the rooms will be placed in the core. Okay, so in this particular floor plan stage, the first is like we are going to be deciding all that particular boundaries. The first step, if they are provided, we are going to be utilizing it. Okay, for that particular creation of the deciding area also, we do have a formula. Okay, for each and every step we do perform. We do have a dependency on the cells or pins or routing. It is dependent. Based on that only the area of the core or the area of the chip is decided. Okay, now deciding of core area and die area, and after that we will be performing is, I'll remove the drawing for now. I'll be performing so yeah, placement. What type of placement I need to perform? So when you decide the, let's say you're going to be constructing a home, the first you will be able to get to know is like you will try to acknowledge with respect to the EB, and you will get that particular power where it should be present. You will get that particular power location. The next is like water pipelines, drainage pipelines, and if there are internet connections, cable connections, everything you will tie up, right? Before getting your full construction, you will be able to get to know from which particular location I'll get the water, from which location I'll get the power. So every information should be known. Then only I'll start to construct. So that means I'll just say first is like pads placement or ports placement. Let's keep it simple, like your interface placements. Okay, pads or ports will be placed. And after that, I got the interfaces. After that, I'll be deciding what are power hungry. I'll try to start placing them. Macro placement. After macro placement, standard cells comes next, not now. Okay, there will be some more steps internal to it, but I'm not going to be discussing it everything right now. Standard cells are not going to be placed in the floor plan stage. Okay, so macro placement will be done, and also there will be some more steps which I'm not going to be covering. Let's keep it like something for the advanced. Okay, some blanks. So major is like macro placement to be done in the port placement and macro placement to be done in the floor plan stage itself. Okay, after that, now I know the port locations, I have macros placed, and also there will be also some more rooms which are going to be placed later based on my requirement. Some puja rooms, or let's say like I might divide it and I might place them, right? And also some dining rooms based on my requirement. Divide it and I can keep them, right? If there is area availability, extra rooms, small rooms, I can be able to place it. Guest rooms required, I can be, if there is space available, I need to place them. So for that, each and every room I need to provide the power. Bigger rooms or smaller rooms, I need to provide the power. So first step, I'm done the macro placement, and after that only I'm deciding how much amount of power will be distributed. Is that statement correct? It is partially correct. Okay, it is partially correct. So let's say I have decided an area, and based on that area, can I distribute the power randomly? No, right? Because the bigger blocks will be using more power and smaller blocks are using less power, right? So simply by deciding the area, power distribution is not good. Once I place that particular bigger block, that is macro placement, then I will be able to get to know exactly where that particular power drop is causing, right? That means where that particular small block is not able to get the power, how can I satisfy it? Everything I will be able to get to know properly after the macro placement only. That's why we perform as macro placement, and after that power plant distribution. Okay, so first criteria to make sure the macros get enough power. First criteria, macros get enough power such that when it comes to the internal area other than macro placement, there will be an extra area for the standard cells, right? Small rooms. Will there be enough power for it to be passed properly or not? Without placing those cells, I'm checking it. After placing it also, I have to check it. First, I'm making it assured. Will I be able to have enough power or not? So once I place them, there might be, because of cell usage also, the power gets dropped, right? Then I cannot be able to find it. Let's keep it like two cases, static and dynamic. Okay, static case I'm checking, and dynamic case also I need to check. Okay, before placing that particular standard cells, we are checking the static related. Okay, whether that particular power passage is good or is there any problem, I need to get it verified and fixed. Okay, so power plan, distributing the power by less IR. This is my main usage. When you get power to your rooms also, I should not see any voltage drops, right? If there are any voltage drops, the functionality of that particular device will be working in a differently. High bright light will be working in a low bright, right? So that's what happens. So I have to make sure in this particular power plant stage. Once after that particular light connections are made, if I connect it, then I will try to check it, right? Light 1, light 2, light 3 I have. So if they are serially connected, what happens? Power will be drops, right? Power drops will be there. Serially connected. If they are parallelly connected, it will be working equally,
same.
right? Correct, equally same. So in this power plan, I'm making sure first is like I made serial connections, or let's say parallel connections I have made, without seeing what type of cell or let's say what type of object I'm going to be using there. Made the connections and checked it. Okay, it's good. My power is coming and expected power is coming. Good. I'll move forward to the placement stage. I'll place the small cells now. Okay, I'll place that particular small cells. That means your standard cells are going to be placed here. So coming to this particular placement of standard cells, it's placed. While placing this particular standard cells, we need to observe timing, power, and area. From here onwards, you will start to observe all these three: timing, power, and area. These three are compulsory. It should be optimized, or it should be placed in such a way that I get better timing, better power, and also area is less. I can be able to, in a small area, I can be able to place it such that in the remaining area, if needed, I can be able to pass it to someone. Okay, so there might be chances like you might get more area. Okay, and based on the, and say the adjacent block is having less area, then what we will try to do, in from my space, I'll just partially divide it and give it to it. So that happens based on this particular placement of standard cells. Okay, initial decision is okay based on a logical entity. We have, let's say, count, we have decided and give it to you, but after placing only I will be able to get to know whether that area is enough or not, right? I have predicted this room is enough for 50 people, but what happened later on, due to some extra curricular activities getting added over here, this room is not enough for my 50 people. Then I found out that the adjacent room is having more space. From that, I'll just borrow that particular space. Again, from the floor plan, I have to do. Okay, again, I have to roll back to the floor plan. I have to alter my macro placement and come to this particular placement stage again. Okay. Now, so till here, we have done is like standard cell placement. Everything is good. From now, the connectivity part starts. That is your CTS stage, clock tree synthesis. Okay, clock tree synthesis. That means your sequential circuits needs to work based on the clock only, right? It will be working based on the clock. Now, if I give you a clock in a delay, that means you are working in a delay as well. But I want you to work faster. I want you to communicate with your friend with a slow duration or a faster duration. You want to communicate your friend faster or slower? Faster only, right? We expect to be working faster.
Faster,
That
faster.
means perfect, faster. So that means I have to trigger you both with a minute of seconds, right? I cannot activate both at the same time. As soon as you start to communicate, with a small delay only, he starts to receive, right? If I activate you both at the same time, what happens? There will be disturbancy. The data what your friend is going to be captured, or let's say he is going to be receiving, is like unwanted data, right? And also, as you both are getting activated, what about the power? At the same time, if I need to give 2 chapatis, it's not possible, right? One after the other only I can give you. That means with few seconds change. So that's why we make sure is like in this particular clock tree building, I have to provide you faster with a minute seconds, or let's say minute time. I need your friend to be activated. Okay, so that we will be terming it as queue. So clock tree gets built, let's say making sure the sequential cells gets clocks with less skew and latency. Latency is the delay. Latency is termed as delay. Okay, clear so far? Any questions or any confusions? Clear for everyone? Now, after that, routing. Okay, so we have 3 types of signals. One is clock, power, and your data. So in the power plant stage, we have make sure like the power is connected. That means the power connections are made. In the second case, in the CTS stage, I made sure like the clock pins are connected. And the pending part is the data connectivity, or let's say signal routing. So that physical connection will be made in the routing stage. Physical routing of the wires. In power plant stage, power related connection physically routed. In CTS stage, routing related is physically connected. And in routing stage, clock is the signal connectivity is routed. Okay, so routing stage is your main role. And after completing this particular routing stage, you will be performing as ECO phases only. That is sourcing of files only. Majorly you will not perform anything, but till here is what you will be majorly performing. In ECO stages, it will be faster. Okay, 1 day process only, 1 day or 2 day process only. Okay, now that is based on the sign off stages. The next is I have to discuss about the sign off as well. Because, okay, I forgot to tell this. So for this particular physical design, the tools which we are going to be using is ICC2 from the synopsis, and from the cadence, it's Innovus. Okay, cadence Innovus and synopsis is ICC2. It's a latest version, and also synopsis also gives you Fusion compiler. Fusion compiler means it's an integration of multiple tools together. That means from the RTL to sign off, by using this Fusion compiler, you can complete. ICC2, it's specifically only for the PD. You cannot use it for different, but you can use this particular Fusion compiler for synthesis, for physical design, and also for your prime time prospective, STA prospective, all that you can be able to use this particular Fusion compiler. Okay. So in our particular training institute, we do use this like Synopsys ICC2. Okay, Cadence we don't have it.
Innovus also on the PD.
Yeah, Innovus is also on the PD. I'm not sure about Cadence Fusion tool because I haven't heard so far. They are using different tools for different stages only. Okay, now coming to the sign off stages, first is like timing analysis. Where the tool we are going to be using is runtime, and a supportable tool is like ASIC. Both the tools we require. ASIC is used for extracting one of an input required for your timing analysis. Okay, I'm not discussing about any of the inputs. I just given you the basic idea of what we are going to do it in our particular training. We'll discuss about inputs, what all inputs required for physical design, synthesis, prime time in detail during our course duration. Okay. So timing analysis, the tools which we are going to be using is prime time and ASIC. Here, the prime time is a logical entity tool which you will be performing at different stages. After synthesis, after CTS, after routing, after placement, you can use this particular PD tool. It's a logical tool. Based on the input, this particular logical tool again can be helpful for your physical related operation as well. The synthesis and prime time is a logical entity where you cannot see your design. Okay, you cannot see your design, you can see only the schematic. What is the difference between schematic layout and schematic? Schematic means pin to pin connection with a symbolic representation. That we will be terming it as schematic. That means gate representation, connectivity representation, we will be calling it as schematic. Layout means your instead of this particular schematic representation, you will be having a like cells. That layout window is where you will be performing. Okay, you will be majorly observing the layout window. Schematic is used for your analysis. Okay, if I want to see that particular connectivity from which cell to which cell it is connected exactly, then by using the schematic I will be able to get to know. Okay, so in the layout window we do have is like only cells like this placed, where you can see all that particular cell placement, routing, everything you can be able to observe in the layout window. Okay, the tools again coming back to STA. Now coming back to our particular STA perspective, tools, prime time and ASIC, where you can observe the schematic, you cannot observe the design layout view. Okay, based on the inputs provided, it can be either physical or logical as well. Okay, it can be either physical or logical entity as well, based on the inputs which we provide to the tool. And second is, okay, in this particular prime time we fix timing related. Okay, That means there will be some terms like transition, capacitance, setup, hold. Everything gets crosstalk. If everything gets fixed by using this particular prime time tool. And the fixes, whatever we are doing in this prime time, we will provide it to the PNR. Okay, as I said, right? ECO. ECO means engineering change order. Okay, this is a cycle. Okay, timing ECO will tell, metal ECO will be telling. So like that, different functional ECO, like that we will be having different terms of ECOs. Okay, so timing ECO, in which prime time tool you will invoke based on the output of this particular routed database. You will perform the fixes in the prime time tool. You will fix it and provide it back to the prime time. Sorry, provide it back to the PNR tool, ICC. They will try to source it in the routing stage. They will fix it, and again they will try to provide us the feedback. Whether it is good or whether it is bad, whatever it is, they will try to give us the feedback, and we have to make sure that is observed again. Okay. Fixing of timing and leakage power. I'm using this tool. Okay. Next is physical verification. So in this particular physical verification, we will be observing for few terms like metal densities, okay, and also the terms like LVS, layout versus schematic, DRC, I'll make it more proper now, physical DRC, and densities. Okay, this will be observed and fixed and again provided as an ECO to that particular PNR. Okay, timing ECO, physical verification, where you are observing all the physical entities, or let's say for physical objects related, everything is good or not. That means metal density, area density, everything you need to check it. Okay, such that it doesn't lead to any kind of manufacturing issues. Okay. What was the other stage I have written? ERC. So I'll make it like EMIR, single. ERC and power, I'm going to be checking. Power drop related and the current density of each and every metal will be checked in this particular EMIR stages, which will be done from stage to stage, but this particular EMIR also is done at the sign off stage as well, verifying at the last everything is good or not. Anything is popping up new violations or not, I will need to verify it. So EMIR, where we are going to be checking for the current density, and the power drops, or let's say voltage drop. Checks are going to be performed in this particular EMIR stages. 15, 11, 15. Okay, so clear so far? The next is like what are the stages? Power and EMR. So these are all the sign off stages we will be telling, and also as I said, formality will be performed here as well. Verification and DFT with that particular routed netlist, or let's say sign off to netlist. I need to verify it is good for functionality wise, it is good, and there are no changes with respect to the netlist. We are performing some kind of routing, we are performing some kind of operation changes, right? During optimization, it doesn't change the functionality of the module that I need to verify it. Okay, this formality is a netlist to netlist comparison, and it will be performing pin to pin checks. Okay, for this EMIR, the tools which we are going to be using is Red Hawk. And for physical verification, tools is like ICV and Caliber. For
During
formality, yeah.
so in this course, we will be taught about ICV and Red Hawk also, little bit of.
Yes, yes, yes. So we will integrate this ICV into the ICC2 itself, and then we will be using that particular tool. Separate invocation we don't have it, but we will use is like that particular check itself. So tools is like or conformer. And for DFT, I'm not sure. There are different tools, but I'm not sure about the DFT case. Okay, in this particular course duration, you will be learning about synthesis. Okay, DC shell, tools used is like DC, design compiler, and PNR, ICC2, and prime time for STM. And also for physical verification, we will integrate the ICV into the we'll integrate the ICV to the ICC2 shell, and we will be using it there itself. Instead of invoking it separately, we can integrate it to ICC2 shell, and we will be performing that particular physical verification. Okay, so these are all the topics which we are going to be covering in this particular course duration. So is the basic flow clear for everyone? ASIC flow and PD flow. What exactly we are going to do? Because ASIC flow, as we go as a fresher, that will be one must giving interview question. Okay, so any questions with respect to the theoretical or let's say conceptual wise? No questions? As of now, no questions. Okay, let's do one thing. Let's take a break of 10 minutes. Okay, if there are no conceptual questions, if there are any admin related questions, so after that particular break, we can go to discuss about that. Okay, there will be separate person will be answering your questions for that. Okay, let's take a break of 10 minutes. So back at 11:25. Yeah, I'll ask admin to share this. Back at 11:25, everyone.
Okay, sir.
Good morning, all. I am Vaibhav, manager of VLSI Guru. Am I audible to everyone?
Yes, sir.
Okay. So we will continue the session now. Yeah. So I hope Vishal has given you all the details, the technical details. So I will be looking into the management where I'm looking into the mostly into the placements. So I will just give a 5 minutes brief about how the course will go and what will be the course outcome, as well as how will be the schedule and the placements. I will walk you through which is our e-learning portal and where you will get the e-learning access as well. Let me share my screen. Yes. All of you can see my screen.
Yes.
Okay. So see, I will just give a brief about how the training will go. Then we will start with the question answers, where whatever queries we have, you can ask, and I will try to provide a solution to it. So basically, see, this physical design course will be a 6 months course. It will be 2 months of basics and 4 months of main training. In the basics, you will be learning from digital design. That is, we will start from the scratch and gate or gate. Okay, and then we will move towards the advanced training. We will start with digital design, then Linux, then PD basics. In PD basics, we will be learning semiconductor fundamentals, PMOS and MOS, and then slowly we will move moving towards the TCL scripting. Why TCL scripting? For someone to be a physical design engineer, TCL scripting is must. Now, what is physical design? Physical design is completely command oriented, where there is nothing coding or programming you have to do. It's a complete command language. So from the TCL, we will start slightly moving towards the advanced. Now, for a physical design engineer, it is mandatory if suppose you are applying as a PT engineer in any service-based or even product-based company, what they will ask is the tool expertise. So for physical design, which tool is required? It is synopsis tools. But now in physical design, there are multiple modules are there, such as floor plan placement, synthesis, STA, block tree synthesis. Okay. So with respect to particular module, the particular tool is used. For example, if I want to do floor plan and placement, I will be using ICC2 tool. Whereas if I want to go for synthesis and STA, I have to use prime time tool. So what we'll be going is, once you move towards the TCL, we will be providing you ICC2 tool, and after the TCL, you will be completing the basic training of two months. Once you complete the basic training of 2 months, then advanced training will start. Now, when it comes to advanced training, we will be starting with the project. That is on block level and chip level. So during that, you will be having a 24/7 tool access. So how the tool access will be provided? It will be via server. We will be giving you the VPN credentials through Putty. You will be able to log in, and even how to log in, everything will be teached from our end. This is about the training. Now during the training, as I said, tool expertise it will be there, but once you enroll for the course, you will be getting the access to the e-learning portal. Every candidate we provide the login credentials. So once you enroll for the course, you will be provided with the login credential. Okay. Now, since you will enroll for physical design, this tab will be open for you. Now, if you go inside this tab, you will see the record, the session videos are there. Whatever has been taught in the session. Now, what happens is whenever I'm doing the session offline or even I'm doing online, in the backend the session is getting recorded. Now itself, this demo session is getting recorded in the background. So what happens is, suppose today I conducted a session on TCL, then your agenda is to just learn the things and clarify your doubts. You don't have to make notes or anything. Since once you enroll, we'll provide you the login credential on your portal. Each video will be uploaded. So today you attend the session, you go home after 3 to 4 hours, the video will be there. Then you watch it again, then make the notes. So the session time should be invested only in learning the things and clearing the doubts. That's how you will be having, see, each and every session video will be uploaded over here. Along with the videos, see, when it comes to physical design, there are multiple topics assigned. Now, so if I walk you through the syllabus, this is the basics, 2 months of basic syllabus, and then it comes to the main syllabus, that is 4 months of main training. Now here what happens is, this every topic is associated with the assignments, and these are assignments are uploaded onto the portal. Now if I go into the assignments, see, with respect to floor plan, there are some questions. With respect to synthesis, there are assignments. So these assignments are nothing but the interview questions asked by the industries. Not even the interview questions, but after getting into the industry, you will be attending the client interview. So in the client interview, what kind of questions asked, that are also included in this. So what is the placement criteria? For a candidate to sit for the placement, at least 70% of this assignment should be completed. Now coming to the companies. See, even if it's service-based company or a product-based company, there are 4 rounds of interview. That is, first one is the written test, second one is the HR round, third one is the technical discussion, and fourth one is the seller discussion. Your agenda is to clear the initial 3 rounds. So the basics that we are covering, it is more than enough for you to clear the written test. For HR round, HR is basically to check your basic communication. So for that, during the training, what we are going to cover is, we will be doing the group discussions. We will be asking you to do multiple presentations, as well as we will be conducting multiple mock interviews. Now, when it comes to multiple mock interview, it will be from the industry trainers itself. Why multiple mock interviews? Because once you clear the HR round, you will be going to technical discussion. When you go to the technical discussion, they won't be asking anything regarding the basics. They will be asking, okay, what project you have done, what problems you are faced, and they will put up some scenario in the project, and I will ask you to debug. For that purpose, we conduct the mock interview. So basically, during the training, whether it's a soft skills training, resume preparation, whatever it is, we are there to take care of all the things. What we accept from a candidate, whatever we are taking, he should be thorough and he should be expertise with the tool. That is what we are doing. At the end of 6 months, if you follow the schedule and if you complete the assignment as per the timings or as per the deadlines, then the outcome of the course is, you will be having hands-on expertise in physical design. You can mention the projects that you have done in your CV, as well as if they ask you to implement anything, you will be having a hands-on expertise on tool also. Most of you will be joining with the perspective of getting into the industry. So how you will be getting into the industry? By getting the opportunities and cracking the interview. So giving you the opportunities and supporting you till you get the job will be the responsibility of VLSI. But the 80% or 70% of assignment should be completed first from the year. Till here, any doubts? Okay, Akshay, Anil, Bharat, Chaitanya.
Sir, tell me, sir.
Yeah, any doubts still here?
Sir, no, sir, no, sir. Sir, what about fee structure? Sir, tell me once.
Yeah, I will come to that point also. Okay.
Okay.
So
Okay.
now coming to schedule. During the training, how will be the schedule? There are two batches that we have. That is a full week batch, which runs 6 days per week. That is Monday to Saturday for initial 2 months, and then we will be having a in the main training. Friday will be a Saturday, Sunday will be the theory, and Monday to Thursday will be lab. That is for full week. Okay. Now coming to weekends batch, it will be a 9 to 1 theory, 2 to 6 lab for weekend students, Saturday, Sunday. Now those, even if you are a full week, even if you are a weekend, or even if you are attending online, offline, or even if you are not able to attend, whatever session is happening per day over here, that recorded video will be available on your portal for 1 week. So in case if you miss, you go through the video and then again come. Now, when someone go through the video, it is possible that sometimes online candidate lags a little bit and offline candidates are moving ahead, even syllabus is moving ahead. For that purpose, what we do is, once you enroll for the course, we will be creating a WhatsApp group where we will assign a dedicated mentor. So each candidate will be having a dedicated mentor where they can directly interact with them, clarify your queries. The WhatsApp group is there. Suppose you are going through the video, you are not able to ask the question in the session, put your query in the group or put a message in the group that I need a session. So an individual one-to-one session can also be arranged. So as I mentioned over here also, schedule that the student will be provided with the recorded videos for the weekdays preparation. Now, when we say that we will provide you the placement support till you get a job, why? What does it mean? So basically, we are tied up with almost 70 plus companies that include Samsung, AMD, Intel, Wipro, Infosys, Synopsys, and our trainers are working in the same industry. Even sign-ups we have. So we have a good connection, and since we keep the projects updating every after 3 to 4 months. Earlier we were doing on 28 nanometer technology. Now we have introduced 14 nanometer also. So we will be delivering you a sync of 14 as well as 28 nanometer. Okay. Because of this updated syllabus that we are updating as per industry, multiple companies are coming frequently asking for a physical design engineer. So when they come to me asking for a physical design engineer, I will just check how many of them are good and I will forward them. Now, your agenda is to do the training and prepare. Whether you are preparing parallelly with the batch, that is also fine. Even if you are preparing, if you want some time after the batch completes to revise and to gain expertise to do more practice, that is also fine. If you come to us that, sir, I need placement support, we will be providing you the opportunities till you get the job. Now, to give one example, there is a candidate who has done the training in physical design. He applied to a company. Company has taken all the rounds of the interview, but the offer letter was not released. In between, still also we provided in the job opportunities. So in it took one second, please. Yeah. So I have explained all these things. Now coming to the fee structure. See, the fee structure for online, that is fees is 63K plus GST, which comes to around this one. Okay. Now this fees you can pay it in installments as well. Yeah. You can pay it in 2 to 3 installments. To confirm your enrollment, 5K you have to pay. Then within 1 week or 10 days, you have to pay the first installment. After or within 1.5 months, you have to pay the second installment. This is the fee structure. Now, I hope I have explained all the things. We can start with the questions. Let me know if you have any questions. Online candidates as well as offline.
Hi.
Sir, sir, offline also same fee structure, sir.
Fee structure is same for online, offline, full week, weekend, anything. And a candidate enrolling, you can switch from online to offline, weekend to weekdays, anything he can switch.
Okay, sir. When the regular classes start, sir? When the classes
The
will be
batch
start, sir?
will be
Regular
starting from
class.
Wednesday. We will be
Wednesday.
giving 2 days time gap for the candidates
Okay.
to think and enroll. From
Okay.
Wednesday, we will start. The Wednesday, we will be having the first
Oh,
session of digital.
okay. Okay, sir. Thank you, sir.
Now,
A
even if you
person
are
having
having
a
any,
gap of
yeah, please tell me.
if a person having a gap of 5 to 6 years, how he is going to survive? Means you are going to suggest this course to that guy.
See, what happens is there is a hiring through hiring in the industry goes for that coming to the training institutes and sending the good candidates. Now, when I have to send a good candidate, I can refer a candidate if suppose even if you are not satisfying the criteria, that criteria is 2018 pass out, but if you are 16 pass out, right? Now, what is the company requirement? Company requirement is only two things. First one is the expertise, second one is the criteria. So, if a candidate is having the expertise, but if he is not having criteria, he can think of hiring him. Because why they are hiring, they have the projects, they want to put to the projects. But if he is satisfying the criteria, but he is not expertise, candidate company is not ready to hire. So the answer to your question is, if you do good in this, we can provide through references or even through recommendations. But when we will be able to do the recommendation, when we see your performance.
Yeah, I mean, if my performance is good, then that will not matter. That
Yes. So there are multiple ways to this one, either to reference or through recommendation we can do.
because many places, yeah, as you told, like 3 years or 4 years, people means last 3 4 year past out people, they will ask. No, that's why. If I am
Right.
5 to 6 years.
Right. See, I will just give an example. There was a candidate who has completed MTech in 2014. Okay, and then he has done his PhD around in 2019. Okay, and he was working as a professor in engineering college. He has opted for the course, and within 4 months itself, he got placed. He was having a package over there at 6 lakhs. He got a package in a company for 10 lakhs. So teaching field is nowhere related to VLSI. Why the company hired? Even I got a call from a company in the last week where Wipro was a company. They have the candidates requirement. I asked them, okay, what is the terms and condition or criteria? They said that they are okay with the terms and conditions, not as much, but a candidate should be good. So basically they look for the expertise. They give priority to the expertise rather than the criteria. If you ask me that Qualcomm and all, they are strict with the criteria because they are the MNCs. But to start a career with it, there are many other companies. I will not say that 100% companies will hire, but there are 70 to 80% companies are there. They are ready to hire.
Mhm. Okay, thank you.
Any other queries? Offline candidates? Okay. So I will be sharing my contact number. Yeah, I have shared my contact number. If you have any queries, not even in this session, apart from this session, if you have any queries, you can get back to me. I will be there from the enrollment till you get the job. I will be the point of contact. So whatever things or additional support you require, we will be there. And what we do is, suppose we have a 6 months course, module by module, we will go ahead. But in case if you are not able to understand, or if you are not able to perform, for example, TCL batch is done, you attended TCL, but you attended 50% only, not able to attend. We will allow you to attend again. Again, you can revise. Next batch is coming with after a month. You can sit there. You can attend again. So that's how we will be supporting you to upgrade yourself as well as get a job. Even all of you have filled this demo session form also, right? The demo session form that we have shared via status or even through messages also. So those who have filled, we will be sharing the recorded video of this demo session before in between 5 to 6 p.m. You can go through this also, and even if you have any queries, you can get back to me. So that's all from my end. Any queries? Okay.